Hello everybody, my name is Simon Pringle. I run a company called Project Rome. I'm also Professor of Sustainability and Innovation at Chester University, but for the purpose of this, I've got my Leeds City Region hat on and I chair the Green Economy panel. And what I'm going to be sharing with you in a moment are some slides that we're using to explain the pathways work that we've been doing from a decarbonisation point of view. So the carbon reduction pathways study was instructed by the Combined Authority. The Combined Authority, along with its partner councils, declared a climate emergency in July 2019, and along with lots of other authorities, of course. And it took the opportunity to strengthen its emissions reduction ambition at the same time. So it's now aiming to be net zero carbon by 2038, but importantly to have made really significant progress by 2030. The carbon emissions reduction pathway study was commissioned to enable an understanding of how we were actually going to do that in practice. What could West Yorkshire do to reach the ambition? Now, it doesn't go as far as answering which specific measures, policies or actions should be implemented. That's been considered as part of the one of the key areas for the infrastructure framework and some of the next phases of work. But it does look at the different scenarios under which the net carbon by 2038 could be achieved, and there's going to be more on that on future slides. So there are several key messages from task one from this piece of work. First one is that West Yorkshire could meet its target. You'll see there's a range of measures been identified in the study to achieve the emissions reductions between 73 and 82%. And there's a range provided because they relate to the different outputs from the three different pathways or scenarios. The remaining emissions, clearly that doesn't deliver 100%, so the remaining emissions delivered through a combination of increasing our ambitions in certain areas, such as tree planting, high levels of remote working, and perhaps the fact we're all joining this virtually and the experience we've had through COVID means we might have been a little under ambitious, given that this work was done pre-COVID in that area, or supporting on the deployment of innovative technologies. Now, what we're keen to stress there, of course, is that we're not banking on a silver bullet, banking on a technology that doesn't yet exist. What we're really talking about are technologies that are not fully commercial right now, but in the course of events, we may be able to deploy them. There's a number of common deployment levels across all three of the pathways that have been modelled to put West Yorkshire on the pathway to net zero. For example, 675,000 homes are going to need to be retrofitted to energy performance standard C or better, regardless of the pathway. But also to fully achieve our ambition, we're going to need government to intervene both on a financial and a policy support level. So, for example, in areas around the decarbonisation of heat or the decarbonisation of aviation. Baseline, and this relates to the current situation in West Yorkshire. What you'll be able to see very quickly there, the green and purple blocks, is that we're dominated by transport and buildings. For the transport side of things, the road transport elements, cars, vans and HGVs make up the very much largest share, with the non-road transport, aviation, being the only real contributor there. Buildings, well, they're roughly split 2/3, 1/3 between domestic and non-domestic, and that's going to cover flats and homes, of course, of different types, and then offices and commercial premises. The majority of that comes from natural gas being burnt for heating water or heating the space. Now, the industry is relatively modest on that, and that is because West Yorkshire doesn't have the same intensity of industrial activity that, for example, Teesside, Humberside, the Wirral might have with their chemical plants or processing and so on. We've got a lot of glass making, and there's a lot of light industry or medium industry, but not heavy industry. So the energy intensity is much lower. And then the agricultural and land use emissions, relatively small, but that's because of the characteristic nature of the region. And we've included waste as well, so that it's there for completion. So we've modelled 4 pathways, they've been modelled by the study rather, and we're calling these baseline, max ambition, high hydrogen and balanced. The baseline one, that is to demonstrate how quickly the region could decarbonise using policies that are already in place, commitments that have already been made. So it's not a business as usual pathway, but it's a no additional policy intervention, no additional commitments pathway. You'll imagine, I'll show you soon, that that doesn't get us anywhere near where we need to be. Max ambition, totally the opposite end. That is really looking at what we could do if we pulled every lever available to us. And high hydrogen is also a very ambitious pathway, but it looks at the decarbonisation of heat through a major hydrogen rollout, and that is the significant sort of element of that pathway. Again, I'll show you the detail. And then the balanced one, as you'd infer, that is a balanced mix of the different technologies looking at the decarbonisation. It involves hydrogen, electrification, bioenergy, carbon capture and storage, decentralised energy production, all the different things. So it's got a real cross-section in there. Okay. So here's the baseline. This is the existing commitments pathway. And up in that oval in the top right corner, you can see that the reduction from the current position is only 32%. So really doesn't get us terribly far. All of the sectors there show change, but slow change to switch to low carbon heat, transport and other practices. Transport sector sees the most progress, but that's really due to the faster development of technology ready, cost effective solutions and leading to uptakes of the uptake of electrical vehicles and so on. The majority of emissions in the buildings and industry sector, that's due to the decarbonisation of the national electricity grid. So that's not really interventions we're making locally, that's reduction in carbon grid mix, as we call it. There's a relatively slow uptake in low carbon heat due to high costs, low awareness, and consumer behaviour challenges. And the agriculture and land use emissions, modest though they are in comparison, do actually grow a little bit because there's an expectation of greater intensity of use and pressure for food output. Power sector down by 26%, and that's really an efficiency improvement based on energy from waste and still phasing out some of the fossil generation. And the remaining emissions at the end, obviously pretty much mirroring where we were to begin with, dominated by the buildings and the transport sector. So that's not terribly exciting. The next one is electricity-led decarbonisation. This is the one we were calling the max ambition approach before. What that shows is the 82% reduction. So that's the most full sort of end of our range. All sectors see rapid change, requiring strong incentives for consumers and for businesses to switch to low carbon heat, transport and other practices. The remaining emissions in 2038 are primarily in transport and buildings, although both sectors see significant electricity usage, so they're going to decarbonise further as the national grid decarbonises. Transport sector, rapid uptake in EVs, alongside a significant shift in consumer journeys and increase in active and public transport. The building sector is seeing a very ambitious rollout of heat pumps. We think around 665,000 of them in domestic systems by 2038, and heat networks, particularly between 2025 and 2035. So we've always got some of those in the region, but there would be a significant increase. And large-scale building efficiency retrofits within this decade, within the 2020s. Industry focusing on developing new technology and switching to low-carbon fuels and hydrogen available to select industry sites through dedicated power lines, pipelines rather. And the power sector seeing a rapid rollout of solar PV, onshore wind, energy from waste and carbon capture and storage within the next decade by 2030. And this is quite a similar one, but it's got a very significant led decarbonisation, slightly less progress made, 76% rather than 82%. All sectors seeing a rapid change, yes, partly enabled by transition from natural gas to hydrogen to be used in hydrogen boilers, vehicles, power generation. So hydrogen conversion is a significant infrastructure challenge. There's a lot of work being led by our colleagues in Northern Gas Networks and Cadent, both here in this region and elsewhere, particularly across the north of England. Transport sector seeing significant uptake of hydrogen fuel cell vehicles, particularly in the heavy goods sector, with buses as the large vehicles, although the assumption is that battery electric cars will be a significant share of the vehicle fleet, the lighter vehicle fleet. And a shift in journey to active and public transport still occurring gradually between now and 2038. And when we talk about active transport, by the way, for those of you who are not familiar with that phrase, that just really means walking and cycling. So that's very positive from a health point of view as well. Buildings and industry sectors, heavy reliance on the conversion of natural gas grid to hydrogen by 2038 for that low carbon heat. 2020s, we'd expect to see hybrid heat pumps and energy efficiency measures being implemented. And then by 2038, over 500,000 homes heated by hydrogen. Power sector and land use, pretty much the same as the previous pathway, previous scenario. And if a mix of technologies are adopted, well, 73%, so really not dissimilar to the hydrogen intervention. Significant electrification of heat and transport, introduction of hydrogen, some areas of the gas grid enabling hydrogen boilers, but not quite as full a transformation as the last scenario. Progress slower than in other pathways, particularly in the land use sector, because that's broadly down to an uncertainty as to how things can be deployed. The transport sector, mixed rollout, hydrogen electrical, same thing for buildings, and again, similar for power and for land use. So really taking elements of both of the previous pathways and blending them together, that's what we're looking at here. So here's the last slide. This is about, it is a comparison, so how do they compare to each other side by side, and what are the differences? Well, the 2030s, we can see that there are significant emissions remaining. The max ambition pathway, making the most progress through ambitious uptake of active travel, electrical vehicles, heat pumps. Industry has made limited progress by 2030 due to the immature state of certain low carbon technologies. And by 2038, the majority of the remaining emissions come from transport and buildings. So a key challenge there is the stock turnover rate, when people actually replace fleets or upgrade buildings and so on. And of course, this is about us improving what we're already doing, making things less bad. What we haven't been able to design in here are the choices that we could make that would take us in a different direction. And clearly we are really advocating that we don't make high carbon choices going forwards. Emissions to reduce still further across all of these scenarios outside of our control, but if the overall electricity grid goes carbon zero by 2038. So there we are. That was a really quick blast through. As I say, this is being shared with industry groups and different sectors at the moment, and to get their input and their thoughts and ideas as to how we take some of these pathways and scenarios and decarbonise in practice. You're going to be able to ask some questions later. I'll try my best to answer any of those, but also really open to your ideas, feedback, thoughts and perspectives too. So thank you for listening.